The population of Hong Kong is growing by about 150,000 people a year, due partly to the natural renewal of family generations and partly due to immigration. In addition to population growth, the continuing rise in living standards has encouraged families to seek better accommodation, thus settling in new areas and creating the need for a new mass communications infrastructure. In November 1998, following the inauguration of the direct underground link between the new airport and Hong Kong Island, the Mass Transit Railway Corporation turned its focus to a new line, serving the new town of Sung Kwan O at the southeastern edge of Kowloon. The MTR Corporation awarded Contract 603 for the design and construction of the Black Hill Tunnels to the Dumez GTM Chunwo joint venture. In 2000, following a merger between the GTM and Vinci groups, Dumez GTM's 75% share in the venture was taken over by Vinci Construction Grand Projet. The contract, a 3-year project worth some 600 million Hong Kong dollars, around 85 million US dollars, represented one of the largest undertakings on the new line. The underground work linking Yau Tong Station with Chuk Keng Leng Station included the following: the design and construction of 4 intercommunicating tunnels totaling some 8 kilometers, the design and construction of the ventilation tunnels, the design and installation of the drainage system, the installation of all the network supports, and linking up the 2 stations at either end. The 4 tunnel paths were to meet up deep in the hard rock to form interchange stations with direct platform-to-platform connections for passengers changing lines. The tunnels run through solid granite rock for 94% of their length. Traditional blasting techniques were used, attacking the mountain from both east and west. Thanks to a favorable environment, far from any built-up areas, and therefore without any noise or vibration restrictions, the teams on the east side worked around the clock 6 days a week, tunneling out an overall average of 260 meters a month, with a peak rate of no less than 680 meters in October 1999. Four Atlas Copco Jumbos were used simultaneously for the drilling. The waste rock, nearly 250,000 cubic meters, was evacuated by wheel loaders and dump trucks. The roof and walls were supported by a layer of wet shotcrete between 5 and 10 centimeters thick, with grouted rock bolts and Swellex bolts. On the west side, things were not so simple. Due to strict urban constraints in the presence of road systems and dwellings overhead, blasting operations were restricted to an extremely tight firing window. Despite these limitations, the average monthly progress was 210 meters, with a peak rate of 300 meters in November 1999, thanks largely to good site organization and to teams working 12 hours a day, 6 and when possible, 7 days a week. At the end of 1999, just as the operation was reaching peak efficiency, our operations were brought to a halt by a weak zone of hydrothermal origin some 25 meters long, which the preliminary geological reconnaissance had not detected. For each tunnel, we had to get through this stretch by excavating half sections, top then bottom, securing them with H-250 heavy ribs at 1 meter intervals, with shotcrete for filling and support immediately after each blast. Excavation work on this zone was carried out by specially trained teams working non-stop 24 hours a day, 7 days a week. This naturally called for a more complex work organization to be put into place, and for miners and supervisors to be assigned specifically to the task. The weak zone was crossed at a rate of 50 centimeters a day in its upper part, and 1 meter a day in the lower part. Our maintenance and mechanics teams worked flat out to meet this management and logistics challenge without slowing down the progress of the tunneling operations. This unwelcome discovery nonetheless caused a certain amount of delay, but we were subsequently able to make up for lost time. With the exception of that tricky 25-meter stretch, the terrain turned out to be pretty much as identified in the pre-project study, which provided for 2 types of temporary support: heavy support for the undrained portal areas and light support for the drained tunnel areas. The concrete liner consisted of a first layer covered by a waterproofing membrane, followed by a second shuttered layer 25 centimeters thick. It took 95,000 cubic meters of concrete to line the tunnels. With its technical characteristics and geological challenges, Contract 603, a highlight in the construction of the new line, provided an opportunity for the Vinci Construction Grand Projet Chunwu joint venture to showcase its underground engineering expertise. The project witnessed significant technical innovations, such as the first ever implementation of a new type of drainage layer. A system of polyethylene egg boxes, as we call them, was installed under the invert, forming a network of intercommunicating conduits, thus eliminating any risk of clogging and draining off the seepage water rejected by the waterproofing membrane. Another major innovation was the use of 10,000 cubic meters of final shotcrete lining over membranes and recesses and intersections. The 4 parallel tunnels are horseshoe-shaped, with a maximum width of 5.4 meters, a height of 5.1 meters, and a combined length of 7,626 meters. The ventilation system comprises a shaft 42 meters deep and 10 meters in diameter, and 250 meters of galleries, all 6 meters across. We also dug out 13 bays for pump and fan stations, averaging 25 meters in length, as well as 6 communication and liaison tunnels. At its height, more than 600 people were working on the job, including about 60 management staff and 20 expatriates. Throughout the project, our approach centered on offering technical innovation with strict adherence to the cost, schedule, and quality requirements, all in a spirit of dialogue with our client, who showed great openness and a clear willingness to apply the ground rules for a successful partnership. With the 4 tunnels completed, we stepped down to make way for the contractors chosen to lay the tracks and fit the signals and other equipment. And on the 18th of August 2002, the new underground line was inaugurated, 6 months ahead of the original schedule.